Hi everyone, in this video walkthrough, we'll be going over problem 11 on CS61BL Summer 2021, the final. And before I start this video, a quick preface. I think I really enjoyed my time with CS61BL, and it's a little sad that this is my last video I'll be recording, but I'm also happy because I really enjoyed this problem, so hopefully you all will enjoy it too, even though it might have been hard on the final. And if you're watching this like years from now, this may not make much sense, but yeah, I don't know. It'd be cool if I'm still around years from now. Anywho, diving into the problem states, suppose we have the int list and fraud list classes defined below. So we see here we have the int list class, and it's very similar to the int list class we've seen previously in pre-midterm 1. And we can see we have the fraud list class here, which extends int list. And we won't really get too much into the detail of the implementation. We will, however, revisit this when we get to that part of the problem. So the problem states, implement the method find frauds, which accepts an array of int lists in which some of the elements are or may contain fraud lists. That is, the dynamic type of certain int list instances is fraud list. As shown above, a fraud list is an int list whose size method returns the negative of the correct size. So our task, this is very, very important here, so I want to actually highlight the sentence, is to report these fraud lists by non-destructively returning a new fraud list containing all of the fraud list instances linked together in the order they appear in R. Okay, so it continues to say you may not modify the given array R or the int lists inside a fraud list. You may not use instance of, get class, is instance, or any method not explicitly written in the classes above or imported. An instance of the problem is shown below. So we have some instance of the problem here. I'm just going to quickly get rid of this for now. And all that we're really doing is we create 3 int lists. We create 4, first, second, third, and fourth, and we put them in an array R. Okay, and then what we do is we call find frauds on this array. Okay, so visually how we can kind of think about this is that let's imagine an int list we draw with this red box. Okay, and a fraud list we draw with this green box. Okay, so when we're looking at this array, what I want to notice is that it kind of just looks like there's some fraud lists here. All we have to do is find these fraud lists and put them in this new array, or in this new fraud list. Okay, so the problem as a whole, I think it seems doable, but the trick here is how in the world can we iterate through all of these elements, given the scaffolding that is there, right? But I'm getting a bit ahead of ourselves, so let's look at the rest of this paragraph. So it states here, after executing the lines above, frauds should be equal to the fraud list with the elements 1, 2, 3, 4, 5, and R, as well as the contents within R should be unchanged. Okay, so what really should be happening here is that when we run find frauds, we should take the elements 1, 2, 3, 4, 5, put them in a new frauds list. 1, 2, 3, 4, 5. Oh, shoot. Okay, and then we want to be returning a pointer to the first link in this fraud list. Okay, so this is definitely going to be a pretty challenging problem. And I think we should try to get started by just looking at the skeleton code provided, because the skeleton provided is definitely pretty intimidating. So what we'll see here is that the first thing we do is we create this array copy. Okay, and then we copy all the elements from R into copy. So I think it's really, really important here to visualize what this is actually doing. So let's kind of take this, duplicate it, and then kind of move it down here. Okay. So what this step is doing is we have R, okay, and now we create some another array called copy. So all that copy is, let's kind of call this one copy. We have to make this a bit smaller. Okay, so when we're looking at copy, notice that when I do array copy, all that I'm doing is I'm taking the value of each of these and setting them as the values of each of these, right? So the value at this index is a pointer to this link. So the value at this index is going to be a pointer to that same link, right? And then what we'll notice is that this is really how copy looks. Sorry, the drawing is a bit confusing, but what I want to emphasize is that R and copy are essentially pointing to the same linked lists, okay? Maybe this might help if these are a different color. Okay, then we could change these arrows to be the same color too. So notice here that R and copy are pointing to the same linked lists, right? And now what we'll notice is that we have some call to helper that takes in, well, it looks like copy. So let's just kind of put that in there for now. And it takes in some index, okay? Let's just keep track of that here. Okay, and we have the following skeleton code. And at this point, what I really want to emphasize is that we'll notice that this problem has to be solved recursively. Okay, so my insight, if I were approaching this problem as a student, the first thing I realize is that we have to solve this problem recursively. Okay, so like how exactly could we solve this recursively? Well, one way that we could solve it recursively is that I could always have a pointer to the current link that I'm at. And then every time I keep changing this int list, right, until I have pointed to every single link. That's like one way of thinking about it. But the main problem here is that we cannot store a pointer to any specific link as we iterate through our recursive calls because we don't have a parameter, right? So my second insight here, I'm not a huge fan of this blue color, we're just going to black, is that we cannot store a pointer to an int list instance since we only have two parameters, right? And the two parameters, just to recap, are going to be our array and some int index, okay? So intuitively, the index is probably going to be one of these values, right? And it's probably going to correspond to the int list that we're currently looking at. So the real challenge for this problem is when we're approaching our recursive calls, how possibly can we iterate through all of these linked lists if we can't store a pointer to an int list instance, right? All that we have is we have an array and we have an index. But the catch here, I think this is really important, not the catch, but one like insight that we can kind of get is that we don't actually have an array, we have a copy of the array. So why did we create a copy of the array, right? Well, what we want to realize here is that R as well as the contents within R should be unchanged, right? So the only reason we would possibly create a copy is so that we can change the copy somehow, right? You guys kind of see where I'm going with this? So the idea is that I can't change any of these black pointers. I can't touch any of the black pointers because R, as well as the contents within R, right, all of these links, must stay the same as I do my recursive call. What I can change, though, this is very important, is copy, right? More specifically, I can change these gray pointers, right? Because I have access to copy. So what if when I am at index 0, this is the really, really cool insight here. Let's say I'm at index 0. So the first link that we want to consider is going to be this link. And it's going to be what copy of 0 is pointing to, right? The second link that we want to consider is going to be this one right here. Well, why can't we just have copy of 0 point here now, right? Because we're done considering this link, so I can just say, okay, copy of 0, you're now pointing to the next link. And what we can do is that I can keep reassigning copy of 0, right, to keep pointing to the next link in this linked list. I think this is a really, really cool and pretty different way of kind of approaching these linked list problems. So eventually what's going to happen is that copy of 0, once it hits the end of this linked list, because I keep moving it one down the linked list, is eventually going to hit the end and it will be null, okay? Once copy of 0 is null, what we want to do is we want to take this index, right? Currently the value of the index is going to be 0 because we want to start in the beginning because we have to get these fraud lists in order, okay? We still haven't talked about how we're figuring out the fraud lists or how we're adding them to the new fraud list. All I'm discussing right now is how we could possibly iterate through this linked list, right? So the idea here is once copy of 0 becomes null, in other words, it's pointed to all of these links, and then now it's equal to null. What we want to do is we want to say index 0, we've exhausted all of the links here. Let's move on to the next index, right? In other words, we should change this index to be 1. And now I repeat this process. When I get to 1, what I want to do is I want to say, okay, it started at 3. Then we set it to the next link, which is null. So then I go to index 2. And then I go to index 4. And then finally, index is going to hit 4, upon which we know we've looked at everybody in the entire array, so we're done, okay? And with this, we can start getting ahead and doing some of the code, okay? So the idea here is that we see that in order to visit all of the links in order, right, we have to visit them in order. The reason we have to visit them in order is because it says right here, linking all the fraud list instances in the order they appear in R. So we need to iterate in the correct order in R. So this is going to be 0, because that's the starting index value. And now when we approach this, what I want to emphasize here, it's very important to understand if I'm given skeleton code, what is each part of the skeleton code giving me the access of doing, okay? So notice here that we have 2 if statements immediately followed by returns. So these are probably going to be our base cases, right? And then we have some stuff here. So then we have some other blue stuff, which we haven't really figured out what we're doing there. But what we can kind of realize is that these 2 more returns are going to be our recursive calls. So let's start off with the base cases. After walking through that example we just walked through, we can kind of notice 2 base cases, right? One base case is that if I am at some index and the value of that index is null, it means I've exhausted all of the elements at that index, right? So the idea here is like, if I'm just trying, let's just like try putting it in the first spot. If I say if copy of index is null, then it says here return null. Well, that's not what we want to do when the copy of index is null. What we want to do when copy of index is null is move on to the next index. So this is a base case, but we should move it here. And then in this case, what we want to do is we want to return a recursive call to helper, right? Because we're repeating the same process. We're still looking at the same array, but now we're looking at the next index. Okay. And the next thing what I kind of want to take away here is that once the index becomes too big, we want to stop. It means we've looked at everything in the entire array. So we want to return null because that's going to be the end of the fraud list we're making. So here, if index is equal to copy dot length, it means we made it to the end, so we return null. So with that, we kind of see we have our base cases done. And what I want to do here in this blue section is we need to somehow we somehow need to change copy of whatever index we're at, right? Recall what we kind of did in this step is I said, initially, copy of 0 pointed here. Every iteration, what I'm doing is I want this index to point to the next link, right? So how I achieve that in code is I say, in order to point to this, right, I can set copy of 0 to be copy of 0 dot rest, right? The only problem there is that we lose the reference to this link. Why do we need a reference to this link? Well, the whole purpose here is that as we're iterating through all of these, we need to see at every point, we ask them, are you a frauds list, right? So when copy of 0 is pointing at this link, the two things we need to do is one, we need to change copy of 0 to point here. And two, we need to store a pointer to this link in some variable, right? Let's kind of add those two steps here. So the first thing we want to do is let's store copy of 0 in some variable. And when I say copy of 0, we mean copy of index, right? So let's say here that int list, let's call it current, is equal to copy at the index, right? And the next thing we want to do is we want to say copy of index, we are reassigning it to be the next link, is going to be equal to copy of index dot rest. Okay. Is it dot rest? Hopefully. Might be dot next. No, it's dot rest. And we could do copy of index. We can also do current here. Either one of these would work. But let's just do current so we could save one array access. Okay, so now what we want to do is that we're at this point in the code. I think it's really, really important to understand where we are in the algorithm we're considering. So at this point, what we've done, let's kind of use purple to distinguish where we are, is I've said current, you are pointing here. The next step I did is I said copy of index, where index is 0, you are now pointing to the next, okay? So the next thing we want to do here is we want to ask ourselves, I'm at current, is this a fraud list, right? How that looks in code, in pseudocode, let's start there, is I say if current is a fraud, I honestly don't know if it's called fraud or frauds list. Okay, it's fraud list. Is a fraud list, then we want to take that first element in current and create a new frauds list, right? So the idea here is we'll return a new fraud list where the first element of the new fraud list is going to be current.first. And the reason I got this line right here is that we know in our new fraud list we're making, the first element should be current.first, right? Let's think about the situation once current is over here. This is the first fraud list we see. We know in the fraud list we're making, it's going to be the first element. So I say I'm returning a new fraud list of current.first, and the subsequent elements need to be the result of the recursive call to helper, right? Because if I'm thinking about my function, what does the function helper return? It returns a pointer to a fraud list, right? So this will be helper of copy and index +1. Oh, just kidding. We don't want to do index +1. We just want to keep the index the same, right? Otherwise, if current isn't a fraud list, then all we want to return is this right here, right? Okay, so the last piece of the puzzle until we're done with this problem and we finished CS61BL final is we need to figure out how to do this check. So this isn't too bad. Using dynamic method selection, what we can kind of realize here is that the static type of current is int list, right? But if current is a fraud list, then the dynamic type of current, right? If fraud list, then this means the dynamic type is fraud list. Well, let's just rely on dynamic method selection. So if I call current.size, notice here what's going to happen is that in compile time, we're in the int list class because current is static type int list. So we will lock in on this method signature. Then during runtime, we use dynamic method selection to actually choose this method signature, and we will return the negative of the correct size. So we can kind of see here that the size here is going to be positive. So this is negative, right? And what we'll realize is that if current.size is negative, we know it is a fraud list, right? So that is all for this question. I hope you all enjoyed this video walkthrough and have a good rest of your day.